Assalamu alaikum. I am Zainab Maqsood from BSBT. Today, the topic that is assigned to me for my presentation is molybdenum. These are the outlines. First of all, what is molybdenum? Then chemical structure and bonding of molybdenum. Then extraction and manufacturing techniques. Then physical and chemical properties. And then applications of molybdenum. First of all, we will discuss that what is molybdenum. Here we can see that molybdenum is present in group 6 and periodic 5, period 5 of periodic table. What actually is molybdenum? Molybdenum is a chemical element that has atomic number of 42. The name is from Neo-Latin molybdenum, that is based on ancient Greek molybdos, meaning lead, because it's all are confused with lead ores. Actually, it was discovered by Peter Jacob. He pastes allowed for close contact between carbon and molybdenite. He then heated mixture in a closed crucible to produce a metal, which he was meaning lead. It is essential trace mineral, as we have discussed earlier that it belongs to group 6 and periodic 5 of periodic table. Then we will discuss the chemical structure and bonding of molybdenum. Molybdenum exists as a dark gray or a black powder with a metallic cluster or a silvery white mass. It is principally found as oxide or sulfide compounds. Here we will see that there are sulfide compounds present. Now we will discuss the bonding that is present in molybdenum. Which type of bonding is present in molybdenum? Actually, covalent bonding is present in molybdenum. The layer of molybdenum atoms that are black is encapsulated by two layers of sulfur atoms that are yellow. The strong covalent bonding between sulfur and molybdenum atoms form the backbone of three-layer structure that is also referred to the single layer of MOS2. Then we will discuss the extractions method. There are many commercial routes for extraction of molybdenum from its sulfide minerals. Molybdenite that involves roasting of concentrate, purification of resultant calcine, distillation of MOO3, but and also hydrometallurgical route. We will discuss some of their. First of all, we will discuss hydrometallurgical process. Is a chemical metallurgy method that conducts separation and extraction of metals based on reaction in aqueous medium. It is extracted from molybdenum concentrate with pressure oxidation leaching. We will discuss that what is leaching. Leaching is a process of solute becoming detached or extracted from its carrier substance by the way of a solvent. This leaching is done by the air oxidation. Here the oxidation of molybdenum is above the 98%. It happens in alkaline solution and extraction and recovery from nickel molybdenum ore. Compared with other processes, total recovery of molybdenum is increased in hydrometallurgical process from 93 to 97%. No, the second method is solvent extraction. It is the most common method of separation of metal ions. The solvent extraction is a process in which solute disturbs itself between two solvents and these two solvents are not soluble to each other. The mechanism of extraction appears to be through the formation of condensed molybdic acid, which is MOO3 2H2O at low pH, and also involve molybdenal species. Here we will see that we have a KSCN solution. Then we will, after 5 minutes, extracted ethyl acetate phase. Then there is a evaporation of dryness, and after heating we will obtain MOO3. Now we will discuss the roasting of concentrate. Roasting is a process in which all concentrated ore is treated with very hot air. The roasting of molybdenate concentrate is carried out by using NaCl. During roasting process, OMA is present both as gas, which is 25 to 40%, and as a solid residue, that is 60 to 75%. Molybdenum chloride and oxychloride condensate both dissolve in alkaline solution with molybdenum recovery up to 100%. Here there is a diagram of roasting process. Now we will discuss the physical properties of molybdenum. This metal is silvery white, very hot transition metal. What are transition metals? Transition metals are that metals that show variable valency and strong tendency to form coordinate compounds. It is often confused with graphite and lead ores, as we have discussed earlier. Its melting point is higher than most pure elements beside tungsten and tantalum. It oxides at elevated temperature. It commonly occurs as dark gray or a black powder with a metallic luster. Now we will discuss chemical properties of molybdenum. It has an atomic number 42 as we have discussed earlier. Its electronegativity is 1.8, melting point is 2610 degrees Celsius, and its boiling point is 4825 degrees Celsius, and it has 11 isotopes. Isotopes are actually those elements that have same atomic number but different mass number. Their atomic mass is 95 and density is 10.2 grams per cube. Now we will discuss the applications of molybdenum. Molybdenum is used as an alloy agent and valuable because it contributes to the toughness of quench and temper steel. Actually, quenching and tempering are the processes that strengthen the materials by heating material while simultaneously cooling in water, air force air, etc. It is also used in nuclear energy application for missile and aircraft parts. Also improves strength the steel at high temperature. It is also used as a catalyst in refining of petroleum in nickel-based alloys, and also act as an electrode used as an electrode in electrically heated glass furnaces. Here we can see a diagram that it has a role in stainless steels of 22%, engineering steels में 41%, nickel alloys 30%, tool steels में 8%, molybdenum metals 5%, and foundries में 8%. Thank you. That is all from my side.